All right, let's talk about the incredible journey of modern AI. Today, we're going to trace the path, the direct line, from the early, basic ideas of machine learning all the way to the ridiculously powerful tools like ChatGPT that, let's be honest, many of us use pretty much every day. Okay, let's jump right in.
So here's the big question, right? How in the world did we go from those clunky, kind of frustrating chatbots of the past to the AI we have now that can write poetry, code, and have a pretty convincing conversation? It's been a wild and incredibly fast evolution. So let's break down exactly how it happened. To really get how we got here, we have to rewind a bit. We've got to go back to the very beginning, to the absolute foundation of it all, the three original pillars of machine learning.
Those three pillars are supervised, unsupervised, and reinforcement learning. Now, for a long time, these were the big three, and they kind of did their own thing. Think of supervised learning as teaching with flashcards. You show the AI a picture of a cat and say, "This is a cat." Unsupervised learning is more like being a detective. You give the AI a pile of data, and it has to find the hidden patterns on its own. And reinforcement learning? That's learning by doing, through trial and error, like an AI figuring out how to win a video game by just playing it over and over. They were all powerful, but they each stayed in their own lane.
But here's the thing. To get to something like ChatGPT, machines needed to do a lot more than just recognize patterns in numbers. They had to understand us. They had to understand our most powerful and messy tool, human language. And that, well, that's a whole different ballgame.
And that's where something called natural language processing, or NLP, comes into play. It's this whole specialized field inside of machine learning that's laser-focused on one thing, grappling with the beautiful chaos of human language. NLP actually borrows tricks from both supervised and unsupervised learning to figure out how to read, understand, and even write like a human.
And you know what? You've actually been using NLP for years, probably without even thinking about it. Every time you ask Siri for the weather, or get help from a chatbot on a website, or use Google to translate a phrase, that's all NLP at work. It's what started to make our conversations with computers feel just a little more natural.
So NLP was a huge step. But then came the breakthrough. The one single technique that unlocked the absolute explosion in AI that we're all living through right now. And trust me, this is where the story gets really, really cool.
It's called self-supervised learning, and it's brilliant. It's a clever hybrid approach where the model basically teaches itself. Suddenly, you don't need armies of people to sit there and manually label every single piece of data. The AI can figure it out on its own.
So how on earth does that work? It's actually kind of simple and genius at the same time. First, you just feed the model a gigantic, unimaginable amount of unlabeled data. Think of it as a huge chunk of the internet. Then the model starts playing a game with itself. It'll take a sentence, hide a word, and then try to guess what that hidden word is. Finally, it checks its own work. It learns from its own mistakes over and over, billions and billions of times, until it gets incredibly good at understanding the rules and patterns of language. It literally becomes its own teacher.
And that, right there, that is the pivotal moment. That ability for an AI to teach itself on a massive scale was the absolute cornerstone, the key ingredient that made large language models, LLMs, possible. This was the game changer.
Okay, so we've got the learning method, this whole self-teaching thing, but what's the actual engine that's making all this run? Let's pop the hood and take a quick look at the architecture that makes all of modern AI possible. So before 2017, AI models read text kind of like we do, one word at a time. This worked, but it was slow, and they'd often forget the beginning of a long sentence by the time they got to the end. But then in 2017, a research paper introduced a new architecture called the transformer, and it didn't just improve things, it completely revolutionized the field. Almost overnight, it became the new gold standard.
So what made the transformer so special? Two huge things. First, pure speed. Instead of reading word by word, it could look at the entire sentence all at once. This made training these massive models way, way faster. But the real magic was a technique called the attention mechanism. It allowed the model to weigh the importance of every word in relation to all the others, giving it an incredible sense of context and nuance that older models could only dream of.
And that brings us right to the acronym you've heard a million times, GPT. Now it all makes sense, right? The G is for generative, because it's great at creating new content. The P is for pre-trained, because it learned from that colossal library of internet data. And the T stands for transformer. that revolutionary architecture that kicked this whole thing into high gear.
So now that we've cracked the code on GPT, it's really important to zoom out, because this incredible technology isn't just about text and language. It's actually fueling an entire universe of what we call generative AI.
Here's the key takeaway. Large language models might be the celebrities of the generative AI world right now, but they are just one member of a large, diverse, and rapidly growing family. So who else is in this family? Well, you have your LLMs, the text wizards. Then you have diffusion models. These are the artists. They're behind those mind-blowing AI images and videos you see everywhere, creating them from just a text prompt. Then there are GANs. This is wild. It's basically two AIs in a competition. One generates an image, and the other one evaluates if it looks real. This constant competition makes them get better at an incredible rate. And you've even got newer tech like NeurFs, which can build entire 3D scenes from just a few photos. It's a whole creative ecosystem.
Whew. Okay, that was a lot. We've gone from the three basic pillars to NLP, to the breakthrough of self-supervision and the transformer architecture. So now let's bring it all home and connect these dots back to the real world.
So, what does all this tech talk actually mean for you? How does this journey from a simple concept to a complex tool actually connect to things you might do every day? Let's get practical.
Here's a perfect real-world example. Imagine you're working with a big, messy spreadsheet. You could literally go to ChatGPT and ask, what's the best way to analyze this data? And it might not only give you great advice, but it could even write the actual code to do the analysis for you. Right there, in that moment, you have a direct, powerful connection between cutting-edge AI and data science. It's right at your fingertips.
So think about the journey we just took. We went from AI models that needed a human teacher for every single step to models that can essentially teach themselves by consuming the vastness of human knowledge on the internet. That one single leap, the shift to self-learning, is what created this entire AI revolution. Which leaves us all with one massive, incredible question to ponder. If AI can now teach itself, what's the next great breakthrough just waiting for us over the horizon?